Okay, so we're writing in Cartesian form, and when you have these questions, a lot of these regions and planes questions, we've got to deal with a Cartesian form. Okay, so what we've got here is first of all, we've got to write this out. Z, we're going to replace with x plus y I minus I, and we're doing the modulus of that. Now what we do is we're going to do a little bit of grouping, but I'm going to skip a step. The modulus is the square root of the real part squared, which is just x squared plus y minus 1 all squared, because we're going to have I, y minus 1, and we're looking at the imaginary part squared. You don't have to do that, okay? That is equal to 1. So it's saying right in Cartesian form it's worth 2 marks. We need to see some method mark. So this method mark being here, and the second. Now, by the way, all these 45 marks I'm going to go through in this video, I don't use a calculator once. Okay? That doesn't mean to say you can't use a calculator, but remember, you've got to show method marks. So with these sort of things, show your algebra. Therefore, we're going to square both sides, and we're going to say x squared plus y minus 1 all squared is equal to 1. Now, not that we have to do this, but what is this? This in Cartesian form is a circle. Its centre is 0, 1, where that's 0, 1, and we've got a radius of 1. That is not required. All is required is this. That is what we require for 2 marks and some method. Okay? There you go. We've done that in under 2 minutes. How long have we been going for? We've been going for 1 minute and 46. Okay. Find the point of intersection of these graphs. Well, you can notice that they're both equal to 1. And they're actually both going to be circles. And as it turns out, we've got a circle. We're actually going now, you could draw this just to get an idea, but you've got a circle with centre of 1, 0. We've got a circle of centre 1, 0. And that is going to look something like this. And it's got a modulus of 1. And then we've got a circle at 0, 1. And that is going to look something like that. Okay? Do you have to draw that? No, you don't. Find the intersection. Therefore, what we're doing is from part A, we can say that x squared plus y minus 1 all squared, and I'm going to let that equal to x minus 1 all squared plus y squared. That's this one here. That's this guy here. Okay? Now what I'm going to do is I'm going to then expand that out. I'm going to get, that's x squared plus y squared minus 2y plus 1 is equal to x squared minus 2x plus 1 plus y squared. They're going to cancel out. They're going to cancel out. They're going to cancel out. Therefore, we've got y is equal to x. Now, we're not done yet though, because we're not asking for a Cartesian equation. We're finding the points of intersection. But I've drawn these two circles, ladies and gentlemen. Where are they going to intersect? 0 and 1, 1. You do not need to show any method mark for that, because the answer, so this is going to be your method mark. And your answer mark is going to be for 2 correct points of intersection. By thinking logically, sketching them out on an Argand diagram, I think it's going to be quite obvious. So therefore, we're going to say intersect at 0, 0 and 1, 1. If you think about it, y equals x. Y equals x. The line y equals x. 1 equals 1. Is it going to be 2 equals 2? No, because the modulus is only 1. Okay? So far, there you go. We've done 4 marks in 4 minutes. We're on good track. Sketch and label the graphs of this. Well, haven't I just done that before? So why don't I just do it again? This time, okay, this time we sketch it out like so. Pretty rough sketch. And therefore, what I do here is I'm going to draw the corners of each circle. I'm going to say that the corner of that circle is going to get to there and there. So now that means I can draw a pretty decent circle. Okay. I would still get full marks for that, but it's a pretty ugly looking circle. You can do a better job than that. Sketch and label the graphs. So we've got to label them. So which one is this one? This is z minus I is equal to 1. And this one here is z minus 1 is equal to 1. Okay? These are circles of modulus 1, and the centres, you can see here, the centre is going to be 1, 0. And the centre over here is going to be 0, 1. Okay, when we're talking about the real imaginary. There's another 2 marks. We've done that in 5.5 minutes. Find the equation of the straight line which passes through the intersection of graphs with this and this. Haven't we just found that from when? From B? What's the equation? Equation y equals x. How many marks is that worth? It's 1. So do we need a method mark? No, we don't. We've already shown a method mark anyway, but we don't need it. That's what the answer is, okay? Y equals x. Now, the straight line found in D can be expressed in the form z is equal to a z bar. Now, first of all, what is z? Let's say let z is equal to what? X plus yi. So therefore, z bar is equal to x minus yi. Now, we've got x plus yi is a times x minus yi. So let's do that now. And you can find a quite easily. Now, this is worth 2 marks, by the way. So maybe you're definitely a method mark. So we've got, and what I'm going to say, though, is we know what's one point that we have. Is 0, 0 going to help us? We know that 1, 1 is a point of intersection. Would you agree? So therefore, I'm going to use that point, and I'm going to say that we've got x plus yi, because that's z, is equal to a x minus yi. Okay? And 1, 1 into this. So what we're going to do is, therefore, we can say that x plus y, or sorry, x 1 plus I is equal to a 1 minus I. And we need to find a, don't we? So a is equal to 1 plus I over 1 minus I. And we're going to multiply through by the conjugate. So I'm going to multiply by the conjugate of the denominator, which is 1 plus I over 1 plus I. And therefore, I'm going to get, now I don't have to show all the working, but 1 times 1 is 1, I squared, that's going to subtract that 1. So therefore, it's going to be I plus I, which is 2I. 2I over, we know that we're going to get rid of the imaginary part in the denominator. So 1 times 1 is 1, minus I squared is plus 1. 1 plus 1 is 2. So therefore, A is equal to I. And that's your answer. Now, that was worth 2 marks. What's your method mark, do you think? Well, our method mark is probably doing this, and our answer is this. So therefore, A is equal to I. And have a look. It says, you read the question, what does it say? A is the element of complex plane. All right, so we've done some more questions, and we've only gone for 8 minutes. Now, it says shade the region. A lot of the time you're shading intersections. Shade the region, the intersection between the circle, which is less than or equal to 1, and where that intersects with the other circle. And be careful to look at, very careful to look at whether they're inclusive or not, because that means if it's a dotted line or it's inclusive. Now, it therefore says that over here, we just go over here. Where do they intersect? And it's inclusive. This is your shaded region that we're talking about. And that shaded region was worth how many marks? 1 mark. Okay? And just make sure that that line is inclusive. If it wasn't, you'd have a dotted line. Make sense? Awesome. Okay, we're going to keep going then. Now it says find the area of the shaded region. Now the area of the shaded region is probably the trickiest question of the whole lot, and it actually uses what? What does it use? What does it use, and what do we have to do? The area of the shaded region. Well, what's the area of a segment? Can someone tell me what the area of a segment is? What is it? So a half, r squared.
Are we finding one for pi slice or just the...
No, what I want to do is I'm going to work out the area of the segment.
Yeah, go half bracket theta minus sine theta bracket r.
Theta minus.
We're not finding the slice.
No, what I'd like to do, ladies and gentlemen, is we want to find we've got to find the area of this segment. But there's how many of them? There's 2 times that. So the area of one segment is, I'm going to show you, and I'm not going to, I would like you to realise that the circular theorems are not on your formula sheet, your specialist maths formula sheet. In exam 2 though, where would they be? In your bound reference, okay? Because you actually do need them, all right? So therefore, we're going to say that the area of this segment, all right, from our circular theorems is actually equal to pi times 1 squared over 4 minus 1 times 1 over 2. Now that's just one of these segments, okay? This is one of these segments, okay? And that's coming from circular theorems, all right? Now, as it turns out, that's pi on 4 minus a half. Now, therefore, the total area is 2 times that. 2 times pi on 4 minus a half is equal to pi on 2 minus 1 units squared. So, showing the area, now you could have done it other methods, okay? You could have done it other methods, but evidence of your method is worth 1 mark, and that's worth the second. A number of students would get 1 mark for the answer, but not showing enough method marks. I will go through circular theorems after this video, all right? I'm going to continue. We've been doing 12 minutes worth. We've done that question, so we're going to move on, and we're going to move on to 2009 Exam 2. 2009 Exam 2. Exam 1 and Exam 2. So we're over here. Now, all right, so first of all, it's saying verify that the point 0, 0 lies on L. How many marks is it worth, though? It's worth 1 mark. Some of these are little dinky ones. But what I can say is that I can go straight to this, and this is what I want you guys to be able to do. X minus the left-hand side. X minus 1 all squared plus y squared is the left-hand side. But we're doing the square root of that, aren't we? But the problem is on the right-hand side, we're doing the square root of that. So I'm actually sort of skipping a step, if that makes sense, because we don't have much lines to work with. Is equal to x minus a half all squared plus y minus root 3 on 2 all squared. Is there any issues with that? I hope not. But this thing here, what we're saying is z is equal to x plus yi. And then I'm collecting, so the modulus of z, or the modulus of this thing here is equal to the modulus of x minus a half, and then, x minus a half plus y minus 3 on 2 I, and then you're squaring that, and that's where that comes from. Now, what about it says verify the point 0, 0. So what we say is when x equals 0, y equals 0. Therefore, we can sub x equals 0, y equals 0 in. We've got negative 1 all squared is equal to negative a half is equal to, negative a half all squared plus negative root 3 on 2 all squared. So we can say that the left-hand side is equal to 1, and then the right-hand side is equal to 1. So therefore, since left-hand side is equal to the right-hand side, 0, 0 lies on L. We've just verified it because we've subbed that point in. All right? It's only worth 1 mark. You don't need to do any more working than that. You certainly don't need all of this business. I want you to be able to jump straight from here to here. That's what you need to be able to do. It says show that the Cartesian equation of L is given by y equals 1 on root 3x. Because it's saying show, you must show each step clearly. You cannot use the calculator. You cannot use complete the square or simplifying expressions. You must show it. Okay? So what we're saying is we're saying that x minus 1 all squared plus y squared is equal to x minus a half all squared plus y minus root 3 on 2 squared. Do not skip steps in show that questions. Now, I'm going to now, what I can do though is do this, expand my brackets, is equal to x squared minus a half x is minus x. Minus a half times minus a half is plus a quarter. Plus y squared minus root 3 on 2. Minus root 3 on 2 is minus root 3x. It's like a half of them plus a half of them is one of them. So that is minus root 3 on 2. Sorry, y. I'm just going to rub this out now, because that's in my way. It's easier to write with a pen, trust me. And we've got one last thing. Root 3 times root 3 is 3. 2 times 2 is 4. So we're looking at positive 3 over 4. Yes? Oh, yeah, sorry. I did say that, didn't I? A half plus a half is 1. So, yep, absolutely. Thank you. Now, you can see there that a quarter plus 3/4 is 1. So you can see that we can cancel those out. And we can see that y squared plus y squared is going to cancel out. And x squared is going to cancel out. And what are we left with? We've got minus 2x on the left and minus x. So I'm going to add x to both sides. And we're going to say that that's minus x is equal to minus root 3y. So therefore, y is equal to x on root 3 as required. We have shown each step. We have earned our 2 marks. And you've been given the answer. So if you skip steps and show the answer, you get no marks. Okay? Pretty simple stuff. 18 minutes and counting. Now it says the equation of part L in the third quadrant of the complex plane can be written in the form argz is equal to a. Now that sounds like a lot, but what is this line? Let's think about what this line is. Let's think about this line on an argand diagram. If I had x and y, think about x and y as real and imaginary, and if I was to draw a graph of 1 over root 3x, now think about it. 1 over root 3 is like, what's the gradient? What's the gradient? 1 over root 3, isn't it? So wouldn't this be, would you agree that this would be the run and this would be the rise? Yeah? So given that it's in the third quadrant, then couldn't you say that this point could be negative root 3 and this could be negative 1? Okay, and then that point there, okay, we know it's not a vector, okay, that is what we're after. We're after this value alpha. Yes? Yeah. No. It says here, write down the value of alpha. Arg z is equal to alpha. This is alpha. Oh, okay. Rise over run. Yep. So your rise is, yes. So that's, thank you. So what we've got, my apologies, is rise. I say it and then I don't write it. It's ridiculous. Rise is 1. run is root 3. So this is negative root 3. Thank you. Thanks for stopping me there before I get too far into it. And then this is negative 1. So therefore, what's this angle? What's the reference angle? So what I can say is, we can say that this, now it's only worth 1 mark. So you just need an answer. But it might help you drawing a diagram. It's pi on 6, but in that quadrant, it's what? Is it positive 7 pi on 6? Is that inside the argument? It's negative. A is equal to negative 5 pi on 6. And that's all you need to do. You do not need to write anything else. That's why they've given you no space. Okay? Find in Cartesian form the points of intersection of the graph. Now look, this is just a circle. Modulus of z is equal to 2. Well, what we can say is that if the modulus of z equals 2, then we can say that that's the equivalent of x squared plus y squared is equal to what? 2 or 4? 4. Now, the points of intersection of L. We've got to go have a look at L, but we can tell you that L, the equation of L in the third quadrant, we know that the argument's minus 5 pi on 6, and we also know that it's, what else? We've also got this, don't we? This is in a Cartesian equation. Okay? So, given that that angle is pi on 6, where is it going to? Well, we know that we've got the equation y is equal to 1 on root 3x. Now, when we're doing intersection, so what we're going to do is we're going to call this equation 1 and we're going to call this equation 2. And then we're going to say 2 into 1. Now, this is just my method. You can do other methods. 2 into 1 is going to give me x squared plus 1 on root 3 all squared is just 1 over 3. X squared is equal to 4. Therefore, I'm going to say that that's 4/3 x squared is equal to 4. They're going to cancel out, and I'm then going to say that x is equal to plus minus root 3. We've found 2 coordinates. Now, when x equals root 3, what does y equal? So therefore, we've got 3 marks we haven't done yet. Now this is going to get you, if you get to this point, that'll probably give you a 2nd mark. Identifying these equations and doing a method, but there's 2 points of intersection because x equals plus. Now, if we just sub this into equation 1, sub into equation 2, then that's going to give us 2 coordinates. So plus minus root 3 is plus and minus 1. So therefore, the points of intersection are at negative root 3. Is it negative 1 or positive 1? Negative 1. And root 3, positive 1. Okay, worth 3 marks, and it really doesn't take you that long. Okay, we're going to continue. Sketch L and the graph of z equals 2. This is the sort of stuff that 2 marks, oh my god, z equals 2 is the important thing is it's a circle of radius 2, of centre 2. So we need to sketch the circle. And it's harder to do it on this, so you're going to do a better job than me. Alright? And it says sketch the graph of L. Now you've got to think about it. What was the argument? The argument was negative 5 pi on 6. Isn't this negative 5 pi on 6? This line here? So therefore, this is the graph of L. So this is the graph of L, and this is the graph of mod z is equal to 2. Sketch L and that's all we need. That's worth 2 marks. This line correctly, and be careful because you've got the argument. It has to be exactly on that line. Has to be exactly on that line, and this has to be a circle of modulus 2. If you don't have that circle of modulus 2 and you have a modulus 1, it's 0 marks. Okay? If you have this correct with a circle of modulus 1, you'd get 1 mark. Okay? I'm going to continue. The last part, it says find the area in the first quadrant that is enclosed by L and the graphs of mod z equals 2, mod z equals 1, and arg z equals pi on 3. Well, which one of those is that enclosing? Well, arg z of equal to pi on 3 is definitely inside this region here. Pi on 3 is, oh no, pi on 3 is 60 degrees. So, we rub that out, don't we? All right, we rub that out. And we've got, let's draw out what our regions are. Arg z is equal to pi on 3. Pi on 3 is 60 degrees. So let's just draw what region. We're definitely including that. And we're also including 2, but 1 as well. So therefore, what we can say is that the region we're looking at is an L. This is L here. So what are we looking for? Are we looking for this region in here maybe? What? Thank you. Find the area that is enclosed by, because arg z...
I know it's wrong, but that's also enclosed by 1, 2. Do you know what I mean?
No, it's not.
If you took out 1, it would still enclosed by 2.
It's not.
But it's not enclosed by 1 and...
It's this. It's this region here, ladies and gentlemen. This is what we're after. There's only one answer. We can argue later.
Wait, what? No, what's that?
What? No. Let's think about it.
It will be the same answer.
Arg of z is pi on 3. Z equals 1. So it's enclosed into that. It's enclosed into that. It's enclosed into... So, but L is... and it's also enclosed into L. And arg z is equal to pi on 3.
Oh my god.
So which one is it?
The one
One above? Okay. I marked it wrong in my thingy.
The area will be the same. Yeah. Get the mark anyway.
All right. So find the area. We haven't actually had to sketch the area. Find that is enclosed. Well, the area, once again, using circular theorems. Okay, now I'm going to just really quickly, you guys can research why, but that is the area is 1/12 pi of big R squared minus pi of little r squared. That is going to find for me this area in here. I'll get to why later. Now, what is big R? Big R is 2. So that's going to be 4 pi, and little r is 1 minus pi. 3 pi on 12 is equal to pi on 4 units squared. This is a method mark, by the way. You can have other method marks. You could work out the area of a full circle and another area of a full circle, and you can do this and that, and you can find area segments, but this is the easiest way. Yes, Luke?
So considering the fact that it says arg z pi equals pi 3,
Yep.
that means that we don't include under the graph as well.
Yeah.
Yeah, because that would start from 0 and then just keep going.
Yeah, so arg z of pi on 3 is from there to there. Oops. So from there to there. So it's got to include that, and it's also got to include inside the circle 2, inside the circle 1, like so.
Right. And
Okay.
then it wouldn't keep going down because...
That's right. Yep, because it's got to enclose all of those.
Yep.
Enclose modulus 1, enclose modulus 2, and enclose arg z is 3, and enclose L. Okay? There's only one answer, ladies and gentlemen. All right, I'm going to stop the video there, and I'm going to make a part 2 in a moment.